Right, okay, so we're going from A to G. So we've filled in the travel cost for A as 0. The heuristic said 14, that's the numbers in blue. So we can calculate the F cost. And we got no parent because that's where we started. So we're going to start with that one. So we're going to set A to visited or closed set. And we're going to look at the neighbours. So we've got a neighbour C. So this isn't in the open set yet. So we're going to add it to the open set and do the calculation. So the G cost is going to be 2. So the F cost in total, because the heuristic says 10, is 12. And we're going to put A down as my parent. Another neighbour is B, which has got a travel cost of 1. So its F cost is 9, and that is A. And then we got another neighbour D, which again has got a travel cost of 1. So because we're at the start, there's no additional cost involved yet. So that gives us an F cost of 10. Okay, so we've finished adding all the neighbours. We're going to pick the next cheapest. So the next cheapest, and it's the F cost that we're looking at, is B, which is 9. So we're going to mark it as closed, and we're going to look at its neighbours. It's got a neighbour A, but that's closed, so we just ignore that. It's got a neighbour C. Now the cost to get to C via B is going to be 1 plus 1, which is 2. C's already cost 2, so it's no better, so we're not going to bother updating. Another neighbour is E. This hasn't been looked at yet, examined, so we're going to put the costing in for that. So that's 1 plus 1, which is 2. We can then calculate the F cost of 5. So we put down the parent B. The other one is G, which is where we're heading to, but we don't know that yet because we're not visiting G. We're just going to put down the data for it. So that's cost of 1 plus 8 for G. And the heuristic for that is 0, so the F cost becomes 8. Right, back round the loop. And again, we've got a lot of numbers here, but we're looking in the F column. So we're looking for the cheapest. We've got a 12, a 10, a 5, and 8. So it's going to be E that we pick next. So we pick E, mark it as closed. Look at its neighbours. It's got a neighbour D, which we haven't examined yet. So we're going to do the calculation. So 2 to get to E plus a further 2. So that's going to mark the cost of D down as 4. But we actually, I've been stupid. I was looking at that gap there. We have actually visited D before, and it only cost 1. So there's no updating to do there. It isn't cheaper to get to D via E. The other neighbour of E is F. This one we haven't visited because I'm looking at the screen properly now. It's going to cost me a further 1. So what did it cost me to get to E? It was 2. So the travel cost to F is 3. Using the heuristic, we can get a full cost of 7. So that was from E. Now the other one we've got there, it's also got a neighbour which is G. So let's have a look at that. G costs a further 2. So it was 2 to get to E plus another 2. That is better than the current best cost for G, which is 8. So we're going to overwrite that with 4. We're going to update the parent and say, right, okay, not B, but E. And then we're going to recalculate the full cost. So it's 4 plus 0. So that gives us 4. Then going to run through the algorithm again, and we're going to pick the cheapest F cost. So we've got a 12, 10, a 5, a 7, and a 4. So we're going to pick G. G is where we're going, so we're going to stop. And we're going to write our route down. So we're going to say, we've arrived at G, but where did we come from? So look at the parent, that was E. Where did E come from? Look at the parent of E, which is B. Where did B come from? Look at the parent of B, which is A. Where did A come from? Nowhere, null. That is the start. So that is our optimal route. And what we haven't done, we haven't visited every single node. We've populated the data about all the nodes in this case, but we haven't visited. We only visited 4 nodes out of the 7. Okay, so the Astar algorithm has picked out a sensible route, and we could have visually have seen that. We could easily see that we got like a 1, a 1, a 1. We got 4 1s, so it's always going to be the cheapest. All right, just visually looking, but the algorithm can't look at the whole graph. We have to go node by node. That's why we have an algorithm for it. Right, stop.